you are and what to expect. So Stephen is a bit of an all-rounder really, and it's not the case he's a jack of all trades and master of none. He's very skilled in a lot of really important areas. He was a previous speaker for the Riots Club as well, and he's going to talk to us about the publish or perish culture and the sort of bad signs that it drives, and how as a researcher you can address that head on with a lot of different cool and neat practices. So Stephen, I'll hand the floor over to you.
Thank you very much, Sam, and thank you to Sam and Nadia for organising such a great event this afternoon. So I've called this "Don't Be Bullied into Bad Science" because the origins for this come from a campaign that was launched in Cambridge by Karina Logan and Laurent Gatto called "Bullied into Bad Science." At the time, both Karina and Laurent were early careers researchers and were pointing out some of the inequities in modern day scientific labs, and that garnered quite a lot of support, certainly within Cambridge. So if you want, you can look on the website Bullied into Bad Science for more backgrounds and for actions that everyone can do, some of which I will cover this afternoon. So I would just point out that my slides this afternoon are available at this bit.ly/Eglen-cost link. So all of the links in here, if you want to follow up with further information, this is a hyperlink document, so you can get all the material. And thanks to Ben Farrar and Yvonne Nobis for background material. A couple of declarations of interest. I am an affiliate editor at BioArchive and a senior editor at Scientific Data. So what does it mean to be bullied into bad science? It can mean many things for many people. I've just put 4 of many reasons here. I think most importantly, I think science is a competitive arena. It would be great if we could fund everybody forever and employ everybody forever, but there simply isn't enough money to go around, and so competition is used as one mechanism by which the rich get richer, unfortunately. This leads to many problems, including long work hours cultures in labs where people feel they have to burn themselves into the ground early in their careers to try and get a more stable position. I think a lot of problems around bullying implicitly in labs comes from this race to publish first. The stranglehold that journals have over our culture is just crazy. The difference between getting a Nature paper and something 2 or 3 tiers down has an enormous difference on people's careers, and that shouldn't be the case, I'm afraid. I think this leads to problems such as that scientists, I think a lot of people quite naturally would love to be able to share all their resources so that they can work with other labs. But giving away your resources often means giving away your competitive edge in the current system. And so people are not incentivized to share their resources. And finally, I think all of these pressures mean that the scientific career and family life that people, certainly in early career researchers, will feel this quite heavily, are often in competition. Time spent in the lab is time spent away from your family, and this is, I think, quite an unhealthy thing. So I'd just like to point out 2 of many of the problems in particular, and we can certainly talk at length about other problems. The first one, I think, is going back to the journals. We are evaluated on where we publish, not what we publish, right? When it comes to recognition of our work, once it gets outside of your immediate peer of experts, people look to the name of the journal title or the curious journal impact factor to work out how good your research is, right? So I'm a mathematician, so here's the gratuitous impact factor equation. So it's simply your impact factor is the number of citations in the last 2 years in the journal divided by the number of publications. Right, and how could this possibly go wrong? Well, if you want a big impact factor, you want the number at the top to be as big as possible and the number at the bottom to be as low as possible. And strangely, journals can set the number PY. They can decide which classes of article will appear to try and lower the count for the value P. There's a strong pressure, for example, in China to pressure in journals with impact factors over some threshold. And this impacts on your salary boosts that you may get. So it's no wonder that people feel a huge drive and pressure to play this game. see Ian Edison thumbs 2019 for lots of other ways to inflate and manipulate impact factors. Second problem I wanted to highlight is the famous reproducibility crisis. Okay, so playing devil's advocate for a second, you might say, what's the crisis? Science is getting better, right? This figure 3 I've taken from Fanelli 2012, so it's a few years ago now. They did a study across approximately 4,600 papers, and we're looking for the prevalence of positive results. And you can see in the graphs, we've got along the x-axis time and on the y-axis the percentage of positive results reported. And no matter what your discipline, physical sciences, biological sciences, or social sciences, you can see the prevalence of positive results going up and up over time. So on the surface, that may mean we're getting better at doing, doing science. But what we know is that actually people are being biased, increasingly biased towards showing only the results that they think are important, and the null results are getting hidden. So what can we do about this? What are their solutions? Well, I think it is a difficult area, but I do think there are things that we can be doing today as individuals to try and push this on, and we can talk maybe later about institutional effects as well, maybe in the panel section. So what can you as a researcher do? I think the first thing you can try and do is to forget about the journal title and its impact factor and just share with your colleagues interesting research that you find, right? So social media is great for this. I now rely increasingly on a group of colleagues just who publish interesting papers that they find. I don't scan particular journals anymore. I just try and wait to see which ones are interesting. And when it comes to evaluating research, this is a tough call, right? I mean, we're asked, as particularly at sort of more senior levels, all the time to evaluate research, even if it's outside of our domain of expertise. And it's incredibly difficult. So, there is a big temptation to rely on, proxies for evaluation, such as impact factor. But I'd just like to go back to a little trick, a little hack that Sidney Brenner noted way back in 1995. And, it's not that difficult, right? We should remind ourselves that what matters absolutely is the scientific content of a paper, and that nothing will substitute for either knowing it or reading it. There is no easy way to evaluate research. Metrics I'm incredibly skeptical of. As soon as we think we've got rid of one metric and we come up with something that seems a little bit more, responsible, or call it whatever you like, people will soon game it, right? Scientists are really good at gaming the system and trying to work out what to do. So we can look at preprints, registered reports. And I think it's really, I'm really encouraged to see this growing network of open science and reproducibility crowds coming up around, particularly in the UK, of which the group at KCL, I think, are doing a really great job. So preprints, if you're not already as a researcher using preprints, I'd really recommend it. Here are 9 reasons that PLOS, if you click on the PLOS link, you'll get the full article that show the advantages of preprints. Old diehards who I thought 5 years ago wouldn't be publishing preprints are now publishing them. On the right, you can see the growth of BioArchive over time. Unfortunately, you may not be able to read the months and years, but you can see the COVID effect. So in the last 3 months, there's been this extra boost onto BioArchive because of people submitting a lot more since the onset of the pandemic. Pre-registered reports, I just really wanted to flag them up. I think they're the great innovation. People like Chris Chambers have been doing a great job trying to get these embedded in journals. If you don't know what they are, I recommend you go and look at, for example, the Center for Open Science link. It basically just what I learned from Dorothy Bishop about them a few years ago in her experience was that as a reviewer, she gets to critique the experimental methodology before the experiment is done, right? Improving then the science that is done, rather than just simply critiquing it after the science has been done. So I think this turns peer review into a much more productive and informative experience than it currently is. I wanted to close on some open science ideas in the last few seconds, just to say I'm a big advocate, have done for a long time. people worry about all the negative reasons for why they shouldn't share their materials, and I think it's just silly. Just take the plunge and do it. Most models are wrong, but some are useful. So my equivalent is most papers are wrong, but some are useful. So don't worry if you think that revealing your materials will show that somebody will come along and show you that you're wrong, because there are mistakes everywhere. We just need to get over them. I just wanted to take the last maybe 20 seconds to just highlight one of the open science activities we've been doing here in Cambridge is this notion called CoCheck. So you're probably all in the UK familiar with the COVID-19 model from Imperial. There was a lot of right-wing scandal about how terrible it was because it wasn't open science and nobody could see what it was doing and it was all terribly messy. Well, we actually looked over the code and in Hilda Bastian's words when she saw it, it ain't pretty, but it works. So because it was subsequently made open science, we were able to check that the simulations are reproducible. The results did hold up, and despite the best efforts of the politicians, this model was actually messy, but it did work. And with that, I would like to thank you for listening.
Wonderful, Stephen. As ever, a real nice whistle-stop tour around the real important issues from the sort of researcher's perspective. We have a few questions coming in. I think one that people are still voting, but I think one of the questions that is sort of picked up by a lot of people is just that preprints are not peer-reviewed, and I think this issue has been kind of accelerated and put into saliency with the coronavirus pandemic, given that, you know, we've got quite dodgy things come through. But I wonder whether you could just comment on these kind of comments that keep coming through and persist.
So, I mean, I can give you a little bit of an insight. What happens at BioArchive as an editor is that I'm asked to do a pre-screen of an article just to check that it meets the remit. So I check that it's a research paper as opposed to a review paper, or it's to try and weed out people's sort of summer theses reports or whatever that have just been put up on there. So it is trying to catch articles. But beyond that, you're right, it is not peer reviewed. But so what, right? So there is a problem that someone could just say, oh, I found this on the internet, therefore it's true, right? Just because it's wrapped up as a preprint, right? It makes no difference, I think. And I'd then like to push it back and say, well, okay, it's not peer reviewed, but what if it was? If it was peer reviewed, would it necessarily be any better? We can all look at peer reviewed papers that have fallen short in some way, and maybe we'll hear in the next talk some specifics about what peer review doesn't catch. Right? So people look at peer review and say, well, it's this marvelous thing that we need. And actually, I'm not so sure. I'm very much in favor of post-publication peer review. And peer review of preprints does happen. You can go on to, you can go on to Twitter and you can see people discussing preprints. What you don't see, of course, is that all attached to the front of the article. So yes, a journalist could just download it and just say, oh, well, I've read this, therefore it's true. And I think that's uninformed journalism, not the fault of preprints.
Wonderful. A kind of related question is by James, and he says, do you have a good idea about whether or not preprints lead to better science, or is it still an open question?
I think it's still an open question. I think preprints have a lot of, I mean, if I can go back, I think on my slide, my screen is still live. I think it does lead to better science in terms of, for example, it builds up a community. I like sharing a preprint and then hearing my colleagues comment on it, and it can change it before it actually, is then sort of stamped after peer review. So I think that does help. It does things. I think it gets over the scooping effect, right? People are worrying about, establishing priority, and it pushes it one stage earlier. So, but at least you can get your results out and then not worry about how long it takes to get held up in peer review. So I think that's good. Item 7, I do think it leads to, the earlier it's seen by your community, then hopefully you get more feedback and error reduction. I don't know if there's hard data out there yet, but I would like to move to the model where, where we are just pretty much doing this by default. And I would like to thank funders like the Wellcome Trust and others for allowing us to now cite these, right? Because that's actually having a positive effect.
I do recall a few months ago, many months ago, there was a research that looked at the difference between the quality of how peer-reviewed publications are written and preprints. And I think peer review had an edge, but I guess that's what would be expected if you have many people sort of looking at the document. I'm not sure whether they looked at the quality or the merit of what was being reported. Yeah.
So conversely, I remember a study which, and this is all sort of anecdotal rather than hard, but showed a very high correlation between the preprint and the final output.
Right.
And that has to make you wonder why, what does the peer review process really add? I think we attach too much value to peer review. 2 random people or 3 random people in the world just giving it the approval, and for example, that getting into a top tier journal being such a game changer, to me is just a broken system.
Yeah, and finally, just in the last few minutes before we bring on Elizabeth, there's one which is universities hold the IP or intellectual property of all the research we do. How can, as a researcher, make something open access if I don't own the IP?
Oh, so that is a thorny issue. I'm in a very privileged position because at Cambridge, actually, that's not the case. All academics hold their own IP rather than the university. But I appreciate that's a minority of universities that do that. I would actually then push it back and say to your institution, hang on, go read the details of what I submitted or the PI submitted in the grant, and the funders' expectations now are that these materials should be open access as a thing, and you write a big data management plan. So these 2 things are in conflict, right? And so in my view, the funders pay for the research, and if you say you're going to make your materials available, or that the funders require it available for the next 10 years, that overrides any wish of the institution to claim IP. The problem with IP, as I understand it, is that as soon as you have a difficult discussion, the answer is go consult a lawyer.
Okay, I think that's fair enough. We do have a few minutes left on the clock, so what I will just quickly check if there's any more questions that have been asked. Let's just take a look. I think one of the issues that comes up with sort of registered reports, which are seen as the closest thing we have to a silver bullet in this in sort of dealing with publication bias and bias against null results, but they can be quite laborious and they're not suited for everybody. So what in your view are the kind of limitations and how can you circumvent them?
So as a computational neuroscientist, I wouldn't have the first idea how to write a pre-registered report, because what I do is pretty much sit in front of my computer with a shed load of data, try and analyze it, and as I start to analyze it, I see lots of new ways of doing it. So my pre-registered report would actually probably be quite vague and general about how I would start, but then it would have a lot of incidental findings that then came up. And so it might be quite a weak way of doing it. But I think really what we're talking about is these sort of much larger studies, like, let's say you're doing a large neuroimaging study and you want to have a large cohort of, subjects. It's going to cost millions of pounds to do. It just makes good sense to write something down beforehand and then get your peers who are not involved in the research to evaluate it and say, oh yes, that looks like a good set of protocols to analyze it. And I think I'd like to even mention the idea from Alex Freeman, this Octopus project, where it may be that, for such large studies, you may get funding to do one bit, which is to write the pre-registered report. And then if that's then said, yes, that would be a great experiment, some other pool of people, you know, it may not be the authors who wrote the pre-registered report, but some other group of people could then apply for funds to actually execute that research. So I think pre-registered reports are really good in the domains of, you know, the sort of, you know, psychology. I think has really benefited from them.
Good, thank you, Stephen. So